Hey guys, here we are with another video. Today I'm going to be showing you about Jacob's ladders. So this here is Jimmy, my small Jacob's ladder. I have a larger Jacob's ladder in the basement that I'll stitch into the end of this video as well. But I wanted to take a moment to explain what they are. Simply put, what they are is just two high voltage rails, either AC or DC, with one being ground or an opposite voltage. Simple as you can get. You can make them with just any old high voltage transformer. The higher the voltage, the higher the current, the more spectacular they are. Forgive my cat, his name's Nikola Tesla. He'll be okay if whatever he's gonna do. But anyway, this is Jimmy. He was my first high voltage project, and he has a DC power supply, high voltage DC, that goes ahead and gives it about 20,000 volts. I'll show you that real quick. It's just a decoration in my house. You can see I have it all full of acrylic and everything. So there's Jimmy running. You can see what happens. So what's happening is the high voltage wants to jump the path of least resistance. See how they're tapered at the bottom. Because they're tapered at the bottom, that's the shortest path for current to flow. And so the voltage jumps, creates an arc of plasma. The current starts flowing. And then what happens is the heat from the incredibly hot plasma arc pulls the arc up the ladder. And it pulls it up until it can no longer sustain the voltage for the distance between the two rails. So you can theoretically make this as tall as you want, as long as the rails are correctly spaced. The hardest part about this project is simply getting the rails correctly spaced. But that's Jimmy there, running on DC. And what I built him out of is one of these. This is a fluorescent light ballast. Before we had LEDs, we had those fluorescent tubes. This is what powers that. It gives about 1,000 volts AC out. And if you can see in the circuit, there's several inductors along with the transformers. The reason for that is it's a ballast. It limits current, but not voltage, using reactive power, not real power. And then I have this, which is 1,000 volts. 1,000's not enough for a Jacob's ladder, so I grabbed one of these. This is a flyback transformer. You can get it out of any old CRT TV. And what these are is they're very low current step-up transformers that bring it thousands of times the voltage you put it into it. And they have a series of high voltage diodes in here to rectify the AC and put a high voltage DC out on this wire. But that there is the simplest of high voltage projects, the Jacob's ladder. Now this one, as I explained in the other video, this one, since it has such a low current limit, because of the ballast, because of the nature of the flyback transformer, it would not kill me. It would hurt, it would poke me, but it wouldn't be bad. And I just have this switch here that switches the 120 to the ballast. So this is a very safe, very easy first high voltage project. It's not something that you can mess up so bad that you die. In fact, the 120 volts coming out of the wall is more dangerous than this, because remember, the high voltage is going to be pulled from 20,000 down to almost zilch, because the current capacity is so low in this guy. I'm also going to stitch together a couple of videos of James, the Jacob's ladder. He uses a 14.4 thousand volt potential transformer. He's running at about 2,000 watts. He's 5 foot tall. He's a more serious deal. So stay tuned for the next few seconds to see James in action. Thank you guys.